Right. In this section, we're going to look at a couple of data protection methods with the DLP API. First, masking. Masking is a method where we replace parts of sensitive data with asterisks or other characters, but we leave some parts visible. This approach is ideal in scenarios where we need to protect sensitive information, but still retain parts of the data for reference. Maintaining this context can be beneficial for analytics and troubleshooting. And we're going to look at a few examples. First, look at the name here. The original John Doe is masked to J with some asterisks and D followed by asterisks. We're hiding most of the name, but keeping enough visible for general reference, at least to see the initials. With emails, the original John Doe at example.com becomes J followed by some asterisks, then E at example.com. So this keeps the structure of the email and the domain intact while hiding most of the username, which can be useful for troubleshooting while still hiding, most of the address, or at least enough that it can't be copied exactly. In the case of a credit card number, we're masking all but the last 4 digits. Displaying the last 4 is a common practice as it helps to maintain security while allowing for some reference or confirmation. Finally, for social security numbers, we again only show the last 4 digits, and this partial masking protects the individual's identity while still retaining the last 4 digits for verification purposes, which many of you probably have experience using the last 4 of your social security number for. Overall, masking helps us to protect sensitive information while still allowing for analytics, troubleshooting, or verification where needed. On this slide, we're going to discuss format preserving encryption, or FPE. It's another method of protecting data while using the DLP API. FPE is useful when we need to keep data in a specific format for compatibility with existing systems or processes, but we don't need it to be human readable. For example, if we want to obscure sensitive data, but still maintain the length and structure of fields like names, email addresses, credit cards, social security numbers, like we saw on the last slide, FPE is a good approach. So let's look at these examples on this slide with FPE, starting with the name field. John Doe has been completely transformed. The format remains as 2 words with a capitalized first letter, but the actual name is no longer recognizable. And in this email example, the email structure is preserved, including the format of the username and the domain, but the details of each are changed. Moving to credit card number, FPE keeps the same 16-digit structure with spaces dividing groups of 4 digits, but the number is completely different. And then for social security number, again, the number has become completely different, but the format with 3 digits followed by 2 digits followed by 4 digits is maintained. The values are just completely different. So this allows sensitive data to be secured without disrupting processes that depend on specific data formats, and that makes it ideal for certain regulatory or operational needs. That covers the most important data protection methods to know for the exam with the DLP API.